Hello, my name's Kyle. I'm going to be going over a solution to each Leetcode problem in order, starting with the first problem called twosum. I have done over 1,000 Leetcode problems in the last 5 years or so, 250 or so in the last couple months. I still have obviously a lot to go, so this is kind of giving me a reason to, do a lot of the ones that I haven't done yet. I haven't done a lot of the hards. I've only done 70 or so. But yeah, let's just jump right into it. This will assume that you know the basics of coding. I will link anything that you need to know if you are a beginner in the description. And hopefully at some point I can make some reference videos that will go over some basics like lists, like hash maps. So you can quickly reference a video that explains that type of, that whatever it is, whether it's like a basic algorithm or a basic data structure. But yeah, let's just jump right into this one. So for this one, I will be using Python to code, by the way. We have, it's called twosum. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So this is a slight variation on the twosum problem where you return true or false, whether or not the array has two numbers that add up to target. That does change things a little bit in terms of which approaches we can use. Usually there's 3 standard approaches, but because of this constraint, there's only really 2 that work here. So I'm going to go over 2 of them and quickly explain the third one at the very end if you're interested in that. But let's get started. So the most intuitive approach, and what's usually considered the naive approach, the naive approach is not to say, oh, this is stupid if you come up with it. It's more just this is immediately what will jump to your brain without having to think about how can I optimize this. So in this case, well, we want to find a pair of numbers that sum up to target. So let's iterate over each of the numbers in nums, and then iterate over each of the numbers again so that we get a pair, and we check to see if those numbers equal a target, and if they do, then we will return their indices. So that should be fairly straightforward. So I'm going to do for I in range len of nums, for j in range I plus 1 len of nums. So this is making sure that we don't have duplicates, this I plus 1 right here. So we start from I plus 1 and we go to len of nums, since we're not allowed to use the same element twice. And we simply check if nums I plus nums j equals target, then we will return the indices of those 2 numbers, which are simply I and j. And you can click run. Now, I'm not going to submit this because I'm not 100% sure if this will actually pass the test cases. The follow-up seems to imply that it will, but I also see that it is it could be up to 10 to the 4 elements in this array. So I'm not actually sure if this would pass, because this is what we call an n squared, O of n squared solution, where we are iterating over each pair of elements. So you have n elements times n elements for all n squared pairs. It ends up being actually, I think, the n times n minus 1 over 2, but because of the big O, you can forget about the, minus n over 2 and all of those types of constants. Essentially, this is fairly slow. So we want to find a solution that is faster than this. Well, this is where we will bring in our trusty friend that you will find yourself resorting to a lot, And that's called a hash map. Or in Python, we just call them something called a dictionary. So what we're going to do is initialize a dictionary. Let's call it indices. So it's going to have the index of for I range. Yeah, it's going to have the index of a number. So we're going to map essentially the number that we see to the index that we saw it at. We're going to iterate over each of the numbers again, but this time we're only going to have to do it once. So we're going to have something that's O of n in time complexity, and I'll kind of go over why that is at the end if you aren't super familiar with how dictionaries work. But essentially what we do is we check to see, well, if we're looking at num in our nums array, we want to see if we've seen anything so far that would allow us to sum num and something else to become target. So we want essentially num plus what we're searching for equal to target. Well, if we do some small rearranging, you'll find that we're searching for target minus num if you just subtract num from both sides. So this is where this map will come in. So essentially we check if target minus num is in our indices, then we can return I and then indices target minus num. And then let's say we haven't found target minus num. Well, we're now going to remember that we saw our current num at I. So indices num equals I. And that should be pretty much everything. Let's just double check that these test cases pass. They do. So we can quickly run through an example here. Let's take 2, 7, 11, and 5. Okay. So we look at the first element in this array, and we say, okay, if, well, our target is 9. So we have if 9 minus 2 is in indices. Well, our indices so far is empty. So we know that 9 minus 2, 7, is not in our indices. So we're not going to execute any this line here, and we're just going to remember, okay, indices 2 equals 0. So 2 maps to 0. We're then going to check, I just realized this example is going to terminate really quickly, but we check for I, num, and enumerate nums. So we get 7 is the next thing, and our I is 1, our num is 7. If 9 minus 7 is in indices, well, 2 is in our indices. So we're going to return 1, 0. Okay, so not super interesting, but essentially the reason this is O of n is because we're iterating over each of our numbers, and this line right here, to check if something is contained within a dictionary, is what's called a constant time operation, or O of 1. Essentially, dictionaries, they do some funky magic with the thing that you're checking for. So in this case, let's say we were checking if 9 minus 7 is in indices. It does something called hashing. So we hash the number 2, because 9 minus 7 equals 2. And we go and check this big table that we have called a hash table for whatever 2 hashes to. And this big table, like the lookup for any of these hash values will be constant time, because it is essentially like indexing in an array rather than having to search through each of the elements for 2. So like, let's say, for example, you had a list that was 2, 0. So you kept key value pairs. So 2 maps to 0. Well, you'd have to check through, assuming it wasn't sorted. So let's say 7, 1. You would have to check through each of these elements for 2. But because there's some hashing going on, I'll link some stuff in the description to kind of go over this a bit more if you're not familiar with it. But because of this, it allows for constant time lookup to see, okay, does this hash value 2 have anything within our table? Oh, it does. It has this index 0. So we know that 2 is in our big table. And then it returns, okay, we know that indices 2 maps to 0, so we return 1, 0. That might be not a great explanation. Please let me know if you have any questions in the comments. But hopefully it is kind of a more advanced. It's a more advanced data structure than you'll learn in your first year. So, but it is something that you should still know in your first year. So it's kind of a shame that they don't teach it usually in a first year university course. The other solution that there is let's say you only have to return true or false. Essentially what you can do, and I'll just write it in pseudocode, otherwise known as Python here. But essentially what you would do is you would just sort the array, and then what you can do is initialize these low and high values to the beginning and the end of the array. And what you want to do is you want to try to sandwich in on where the pair could possibly be. So you would say, okay, while low is less than high, since we can't use the same elements twice, so once they're equal, we know that, okay, there's no pair that we can find. If nums low plus nums high equals target, then we obviously know that we can find the target value in one of the pairs in our array. But if it's, let's say, greater than our target, well, what we can do here, so here's a sorted example, is we can take this 2 plus 15, so we see it's 17. We say, okay, well, we need to make this value smaller if we want to find our target that's 9. So how can we make it smaller? Well, if we increment low, we're going to get a bigger value, because incrementing low, you're only changing one of the numbers, and the one of those numbers is getting bigger. So your sum is going to, of the two numbers, is going to get bigger. So what if we decrement our high number? Well, that should make our number smaller, because you're taking the bigger number of the two and you're making it smaller, meaning the pair of them together will sum to a smaller value than when it was a larger, the high number was a larger value. So in that case, we will decrement our high, and then obviously in the other case, you will simply increment your low. And then if you get to the point where you haven't found the pair and the low and high cross, then you know that you can return false. So yeah, hopefully that wasn't too difficult. I definitely can see how my explanation of the hash map might be a bit difficult to understand without the necessary knowledge. So I will try to link some references below and maybe have a video that's dedicated to explaining it, because I think it requires its own video. So yeah, thank you so much for watching, and I will see you guys in problem 2.